Hello. Hello, everyone who's already been here, and hello to the recording, and hello to my IntelliJ window. Can you all see this? Is this a reasonable size?
Yeah.
Perfect, perfect. So today we're going to be exploring more AI stuff. I know Adam and Vigo did a session a few weeks ago, and I'm in fact using Vigo's library behind the scenes for this, but I hacked something together last night. I don't know if everyone has seen, but OpenAI, their ChatGPT, they posted some videos of a new plugin system where basically, that you just give OpenAI, you give GPT access to your APIs via some sort of schema description. I think almost like a natural language schema description, obviously, because it can parse natural language and extract information from it. I'm not entirely sure. I didn't look quite at the docs because I didn't have access to it yet. I don't know if it's an alpha or what, or if anyone has access to the actual plugins. But the videos they posted looked really pretty neat. And I mean, it's sort of inevitable at this point. So many things are just inevitably going to happen at this point with AI, as becoming as advanced as it is. And it just got me thinking that we could do some cool things. And I thought, look, okay, since I can't access their real plugin architecture, let me do something fun with ZIO. I had an idea that's kind of a combination of other ideas, as well, most ideas are. So it's sort of that. It's allowing GPT to, in some principled manner, access APIs that you expose to it and let it call them, but also sort of uses macros to let you write your APIs as succinctly as possible. So what we see here is kind of what all you have to do in this current version, a very beta version of this API. There are many, I'm sure, edge cases that I'm going to avoid with agility on the broadcast, but I'll show a few examples. I hope it makes sense. Basically, what we have here, we have this service, this action service, which just can be a trait or a case class, really just something that has a bundle of methods on it. And these public methods are going to be the ones that the AI can see and can call. So we're exposing a few methods: the ability to add numbers, to get the user's city, to get the weather in a city, and to send a Slack message. Obviously, these aren't hooked up to anything right now, but they could be. We could have other dependencies up here, and those could depend on actual implementations. We're going to see in a couple of examples, or maybe the next one that actually is hooked up to real APIs. But for now, it's just kind of a dummy implementation, which is fine. And then we're kicking this off with this message here, which is Slack me a haiku about the weather. And then also, what's some math? Why not? Let's combine some things. So theoretically, the API with access to these powers might use these APIs in some way to do this command. Let's see what happens. And we're going to get some output on the right-hand side once it starts running. Slack me a haiku about the weather. So that's what we said. And now we're going to see its API calls and the responses we give back to it. So it called get weather with Paris because we gave it Paris, and it got the weather. And then it added
that's actually not accurate, maybe, for Paris, sadly.
Holy crap. Yeah, just that's hilarious. That's just randomly generated. Okay. All right. So it sent a Slack message, weather haiku.
Oh my God. This is dark.
Yeah, let's read this haiku. Let's see if it's a real haiku. Literally fire, flames consume the Paris sky, nature's fierce dance. Again, it's 4. Nature's fierce dance. Yeah, that's kind of a beautiful and dark haiku. And that wasn't planned because I had New York, space, Paris, Tokyo, Sydney, extremely hot and humid, covered in bees, literally on fire. So really only one of these combinations is in any way real. But it's ignoring that dark coincidence, it's also sort of dark or insane that it was able to do this. It's calling these methods. There's no tricks up the sleeve. If anyone has any ideas in the chat, like of another API you'd want to add, or maybe we can modify this to send something else about this stuff, we could see that it's actually calling these. I will source a chat if anyone wants to modify this in some way. But it's pretty cool. Basically, the way this works is there is in this prompt, this is triggers a macro that basically at compile time, as macros do, just introspects this trait, gets all the signatures of every method, the method name, basically just the signatures, and lists these signatures in a prompt to GPT saying, hey, you have access to these methods. And if you want to call them with this very particular JSON RPC format that I hacked together, basically the name of the method and then a list of an array of arguments, essentially, which all have to be primitives at this point, ints, strings, booleans, doubles, JSON types, essentially. And if you do that, then it's going to call this the method and then feed the result back into the chat. So it can use the result of getting the user city Paris to call the weather API with the city, and then get back, in theory, the actual weather for that city. And it's actually doing that. So slack me a gangsta rap. No, I'm not going to do that one because those tend to be very long. That's why haikus are nice for these examples. Poem in the style of E.E. Cummings. Let's go with that about the weather. Yeah, let's just do this. Just to see that it is actually doing things, and maybe it'll explode. We'll see. Slack me a poem in the style of E.E. Cummings about the weather. So it's going to do something very similar. Maybe it added the numbers first this time. I forget what it did last time. Gets the city. Now it's New York. New York is covered in bees. And what have we got for the haiku? There's a bit of a delay because we're basically receiving its command, and this poem is longer than the other one. So the weather in New York, covered in bees, a speck in the vast, the buzzing bleeds, the air alive, wings beat in dreams, the sky an echo of tiny hymns. 2156 plus 2366 computed and yields 4522 proudly revealed. Wow. So it included the math in the poem. Oh, that's all right. And then it gives us sort of the summary answer. Your poem and the results have been successfully sent on Slack. So that's pretty cool. So that's just one example. Let's look at another example that I have here, which also uses services now. So we have an appointment service, a weather service, and an email service. And so the methods we're exposing to the AI are getting our existing appointments. Once again, getting the weather on a particular date, getting all my emails, sending an email. Now these are all actually fake stubs, but it's written at least in a style that it could be replaced with real implementations if you just swapped out real layers down here instead of stub implementations. The command here says, can you read my emails and figure out some good times for me to meet with people and then let them know on my behalf, please. So let's see what it does if given access to these APIs. What's it going to do to fulfill my wishes? Okay, so it got the message, my emails, and these are hard-coded. It got my existing appointments. It got the weather on some dates. It's getting the weather on different dates based on the query, based on the contents of the emails. We'll see. It's sending an email to my mom, and then it's sending an email to Biff. Okay, and now it's probably going to say, okay, I have read your emails and found some good times for you to meet with people. I've scheduled a lunch meeting with your mom tomorrow at 1 p.m. and a football game with Biff on March 27th at 2 p.m. I've already notified them on your behalf. And if you sort of look at the emails, you'll see that Biff wants to play football. Make sure, and he's saying, make sure it's not raining in the next 3 days. And the mom would like to meet for lunch tomorrow or the day after. So let's have lunch tomorrow at 1 p.m. And then that's what it said to mom. And then to Biff, let's play football on March 27th at 2 p.m. The weather should be good. And March 27th at 2 p.m. I'm not sure if I agree that the weather is great on March 27th, but it's
some risks there.
It's certainly better than the other days. I guess not the first day.
Yeah.
Maybe the first day would be the best one, but alas, we were busy. So we had the lunch with mom, and we also had this other meeting. So maybe it had some thoughts. It tried its hardest. We probably could have given it more prompts to be less. You probably don't want to actually give it this much power unless you really really trust it. And or maybe have a draft emails for you or summarize things, and you can verify it manually. But anyway, nonetheless, kind of insane still that it's able to coordinate in this way, knowing that it should check the emails and figure out good times to meet. And, probably could ask it other things as well, yeah. I don't know what else I could ask it to do with these things, but if anyone has any ideas for this one. And then one last one that actually is going to hit some things. So we have another example here. This one, though, does hit real GitHub to get my recent repositories. And then one that actually sends a Discord message on, I just made a fake Discord or a real Discord, but just a dummy one. And the prompt here is to send a list of my repos, only those that mention macros, to Discord. Why not? So I'm going to run this one now with those APIs. And we'll see what happens. Fun. Get my repos, that makes sense. And so it's getting all these repos back. And then it's taking its time to send a message. Yeah, it would be nice to see it's typing, alas. One request for Vigo. Yes, add the streaming APIs to the chat. But here it is. Did you hear that sound in the background? Something happened. Let me switch over to my other screen. Ta-da! There we go. That just happened at 5:14. ZIO magic, compile time business, compile time, quotidian. I can click on this, and yeah, it's going to go to, well, it's going to go to the API address actually. But nonetheless, pretty neat, I'd say. Pretty cool. It's also kind of funny. One thing that this has sort of shown me is how quickly we accommodate ourselves to insane new technology. Like, I'm like, yeah, it's pretty cool. It could have done a little better there. The poem was as good as it could have been. Kind of didn't schedule that soccer on the best day. Exactly. It's kind of raining a little bit. So anyway, it's all nonetheless pretty amazing. Okay. Did we get any suggestions? I'm just going to check the Discord real quick in case anyone had any fun. Okay, just reading through the Discord. No hints, but yeah, if anyone has any ideas for other APIs you'd like to add or just mock out here, we can do that. But nonetheless, it's relatively insane. So if there are any questions, feel free to do that. Otherwise, let's just talk about how it's implemented, which isn't so insane. It's relatively simple. Sorry, my cats are scratching on things. Just want to make sure the world isn't falling apart. I'm making some weird sounds. I don't know what they're scratching on, but nonetheless, cool. Let's look at the implementation. So basically, you call prompt on this chat service thing, and you have to provide sort of a phantom type parameter. This determines the trait. This is going to be the type that gives you provides the APIs. So these are the methods that the AI can call, and it's also the methods that are going to be listed to the AI in some kind of format. And maybe we could actually first just take a look at what that's going to look like. I have something called action macro run on action service, and I'll just ZIO.debug this. And there's just two properties of this thing that it gets back, which is I believe a handler. So there's a macro that's used to generate this handler thing for our action service. And I'm just going to first print out the description because that will give us an idea of what it's doing. So, a description. Look at this. So just a whole bunch of methods, signatures, essentially. And so the macro introspects the trees and gets these method signatures. Oh, no, that's not what I want. I don't know what that was. Come back here. There we go. Okay, cool. Oh, I clicked on my path. Great. So yeah, these are the methods. And we just basically interpolate this into the message we send to GPT-4 as part of the prompt, which is a bit of a long prompt. And people have been making fun of the word prompt engineering, and I've rolled my eyes at it myself. There's certainly a million strange Twitter folks who are just making weird careers of churning out free newsletters or paid newsletters on how to like do AI prompts and NFTs and stuff. I don't know. It doesn't really make any sense. I don't think it's that complicated, but there are probably some tactics you can use to and need to use to make sure that the AI does what you want it to. For me, that involved just rewording and just trying to be very clear in my prompts and trying a few different things, because it didn't always call these methods as I wanted it to in the right order. We'll look at that in a moment, the prompt engineering portion of this. But anyway, the point is this description is going to be spliced into some message that we send, letting GPT know what it can do. Great. And then also, how can it call? How can we call these methods eventually? Because there's no, I mean, there is dynamic dispatch, but we don't really want to do dynamic dispatch. That wouldn't be fun. So the macro also generates this thing called a call, which is basically the following. It takes two arguments. It takes maybe I'll just go to it. It takes two arguments. It takes whatever your service is. Let me rename this to service. And it takes this RPC call, which is basically the method name and an array of any. So it's going to be, and it's going to return a task of any. So it's all type erased and everything, but basically what it's going to do is at compile time, it's going to, and we could look at the macro below if we'd like. There's a macro that does this. It's only 100 lines of code, but it's not the prettiest code because I kind of just banged it out last night. But theoretically, it's going to do the following, or it does do the following. It's going to look at all the methods, and basically it's going to build a big map. So it's going to say map, add numbers, and then the value here is going to take an int, another int, and then simply call on some value of the service, add numbers, passing along the arguments. And it's going to do this with the rest of the things as well. So it's just a map of functions, essentially, and they're indexed by their names. And that's going to allow us to do the following. The AI is prompted to basically send us this format of JSON, which is going to be an RPC, where it's going to first have the name of the method it wants to call, and then the args, which are going to be just an array or a JSON array of the arguments. So, get user city doesn't have any arguments. Get the weather takes just one string argument, etc. So it's a little limited for now. And if we wanted to improve this, we would make it work for, you should, the happy path, as I mentioned, is a bit narrow. These need to sort of be primitives in here, simple JSON analogs, JSON primitive analogs like string, number, Boolean, etc. Because we're basically just going to parse out the JSON values into Scala values and then pass them along. So yeah, pretty basic. Eventually it would be great if you can have like more complicated case classes here, but then you need to have a way of decoding those from the API responses and basically tell GPT, hey, well, how do you want GPT to encode in its string a more complicated structure? And it could just be JSON, but then you'd have to include basically the JSON schema for every type. So if, say, one of these took a city like this, city that had a name, then you'd need to include in your message, you need to generate some schema for this and include that along, saying, well, for a city, it needs to look like this. So wherever you see the city type, that. So basically you're generating a JSON schema of your API or some kind of schema. And I haven't really looked, as I mentioned, at what OpenAI is doing for their sort of plugin architecture. But certainly, I'd say most of our habits for API design are going to be changing in the future at some point, because up until now, we've needed to have very deterministic APIs, right? You want your schemas to be very rigid, so they're parsable and clean and predictable. However, with AI, everything becomes a little wobbly, and it doesn't necessarily need to be so rigid, right? You can adapt. An API can process just natural language into any number of formats. I made a silly tweet today. It was something that's been on my mind for a while. Last summer, I read this book called The Nature of Technology, which is a cool book. Basically talking about what technology is, trying to sort of mathematically come up with almost like an algebra for technology, and look at its compositional properties, and kind of study it as almost like a mathematical object. But it's not that mathy of a book, but it's a really interesting book written by a very smart fellow who knows, I guess, a lot about planes. And he talked about this one thing in the book, which involves jet technology. And in the past, since the Wright brothers up until, I don't know, the 70s, the 60s, I forget exactly at what point this shift occurred, but planes used to need to be designed to be inherently stable. So they needed inherent stability. And that meant basically if you're driving the plane, flying the plane rather, or driving it, and you took your hands off of the wheel, you'd want the plane to continue to fly in pretty much a relatively straight line. Right. So if you went to go take a sip of your Diet Coke in your cockpit cup holder, the plane wouldn't immediately sort of fly off the road. Much like in a car, you have a little bit of wiggle room after you remove your hands from the steering wheel before you fly into the divider. You're mostly going to stick on a straight path for a moment or so, and that makes it a flyable vehicle for human pilots. However, eventually they developed these things called fly-by-wire systems, where they essentially hooked up all the controls to electronic controls, electronic stabilizers. At this point, there's no just direct sort of hydraulics controlling from like the lever that the pilot is pulling on, or whatever, the joystick. That's not actually directly connected by a series of pulleys and strings to the wings. It's probably hitting some much more complicated electronic machinery, which is interpreting it and then controlling the wings with very small, I don't know, servos. I have no idea how planes work today. But the point is, it's technologically advanced, and this happened at some point in the past, at some point after the Wright brothers and before 2022. I think in the 60s or 70s or 80s, maybe 70s or 80s. And when we had these fly-by-wire systems. And when that happened, we no longer needed to make planes inherently stable. Now, a lot of planes still are. Commercial planes are still inherently stable. But for advanced military vehicles, or sort of aerobatic vehicles, acrobatic, sky dancers that need to be very agile and move around very quickly, being inherently stable is actually quite limiting. Imagine like a big, just sort of stiff plywood Wright Brothers style plane. It's just like you can't really go in crazy loop-de-loops with that. You can't dodge a bullet, a big a military bullet with that. But if you instead make your plane sort of made it out of a million movable parts, and it can sort of reformat itself, kind of like some kind of Terminator machine at any moment, well, a human pilot wouldn't be able to pilot that. It would just fly out of the sky. It would just dissolve almost in the air because it's just full of joints. However, with the advancement of technology and fly-by-wire systems, you can sort of relieve the human pilot of that control and allow the technology to stabilize these many, many, many complicated pieces from live feedback from the instruments, which allows the plane to become faster. And it basically totally changes the design space of building aircraft, right? What originally was this hard constraint of your plane needs to be pretty stiff and solid, that's no longer necessary. These other technological advancements kind of removed an earlier constraint. And I'm sure it took time to realize that and to sort of adapt to this newfound freedom, this opening up of the design space. And at the time, which was I think when I read this in last August or even September, there was no ChatGPT yet. I knew there was GPT and all that stuff, but I hadn't played with it much. And I think overall, generally, most people were just less aware of how insanely powerful this technology was. But nonetheless, at the time, I was like, okay, this kind of reminds me of AI, and maybe one day in the far distant future, my cat is afraid. I'm not sure if you hear. She's afraid the AI is coming. She meowed once. at some point in the distant future, I was thinking that this whole inherent stability, inherent instability thing kind of sounds like a similar thing might happen with APIs, because instead of sort of having these, as a person who writes many APIs and many interfaces, right, you need to be very meticulous about making sure you pass exactly the right arguments, exactly the right headers and everything. It makes sense, right? You have to have that accept encoding header or the content type, and it has to be the right one. Otherwise, it's just going to blow up with an awful error. And that's fair, and that makes sense because that's just sort of how I know what's happening on the other side. They have some parsers that are parsing a very exact thing, and every little character is important and needs to be correct. But eventually, we might have AIs in front of those API interfaces, sort of AI adapters. So we have some human-written API, and then in front of it, we put an AI. And on the other side, there's going to be an AI as well. And so really, there might just be this layer of adaptation, this adapter layer, where just two AIs are sort of saying, hey, can you do this for me? And then it's like, let me check. What can I do? Yeah, I can do that for you. Let me take your request and turn it into the actual sort of underlying, more strict, inherently stable API, if you will, and then send back a response in really any format it wants to, as long as the information is there in some way. It could strip information that it doesn't think the other thing needs. So it's like kind of GraphQL on steroids. And then the AI can say, okay, cool, let me put this back into the format that my API needs. And maybe eventually, of course, these other underlying APIs will dissolve as well. And it'll just sort of be AIs generating machine code, which runs directly on CPUs. Or our old sort of standards of machine code will disappear, and it will be some kind of just, neural nets all the way down, storing informations in weird vector spaces. I have no idea. But for now, I think it's probably best just to at least keep something stable, at least so we can imagine this potential future world. And anyway, that kind of reminded me of this, right? So we have these currently, we have these inherently stable APIs that communicate with one another, and soon this AI will allow it to become sort of inherently unstable and just sort of open up the design space in all sorts of ways that are going to be relatively difficult to predict, because we're so used to habitually writing things in a particular way. Anyway, sorry, Adam, were you going to say something? I've been going on about this.
No. I mean, I think it's all interesting. I guess one of the things that strikes me is one of the things interesting, like by the fly-by-wire idea, is it's probabilistic, and you see the same thing with this, that like if you look at these API calls we've been doing, there's a little bit of randomness involved, right? And part of that is you introduce the randomness, like which city we get. But even aside from that, we may get a nice haiku, and then separately we may get the addition of our two numbers, or we may get the addition of our two numbers as part of our poem.
Yes.
And and right now it doesn't really matter, but sometimes it can matter. And like in the fly-by-wire case, I think the way it works is like at any given point in time, the system is kind of making an estimate of like what it needs to do to course correct, and that estimate could be wrong in that moment. But the idea in that case is that it's readjusting itself at a high enough frequency that even though at any given moment it might make the quote unquote wrong decision or a suboptimal one, the odds that it does it for long enough that it actually caused an issue for the plane are vanishingly small.
Sure.
And I think that is going to be an interesting potential change in the way that we think about things, because I think most of the things we do as programmers are not probabilistic, right? Maybe we have a few if we're like, well, if we use UUIDs, then the odds of us generating duplicates are vanishingly low, or what have you. But most of the time when we do things when we're thinking about like concurrency bugs, we're not like, well, it's very low. It's like, no, like if you look at this system, it's like provable, and if we think it's provable, that there's no way that this state occurs. And I think that's something that you're not really going to have with these AIs necessarily, right? Because it's just a black box. Like there's no way to kind of look inside what ChatGPT is doing and be 100% sure that it's never going to do this. So what do we need to do to have systems that are resilient to that at a higher level?
Yeah, no, that's that's I'm very glad you're here because yes, I'm sure you know way more about fly-by-wire. I only read about
I think it's not like I'm like an expert.
in,
I guess I was a pilot for a little while, but
oh my God. Well, there you go. I forgot about that detail. Okay, that's amazing.
just small planes. Probably not that stable.
Not the super acrobatic ones.
Not the super acrobatic, but also not the super big ones.
Okay. Were your planes inherently stable, or did they have these fly-by-wire systems? Or I guess they all have those a little
I
bit.
think they all had some, but not like you would have in like a really fancy plane.
I see. But yeah, exactly. I guess sort of what I was thinking about this, because I was, I was kind of arguing with myself in my own head when reading this stuff, which is that okay, there's this AI stuff, but inherently, I think my knee-jerk response to this of APIs communicating with one another is exactly kind of one layer of what you were getting at, which is that that's going to be chaotic, that's going to be insane, that sounds really inefficient, and also, yeah, there's going to be all these kind of errors, and it's not going to do the thing I want it to do exactly. But I feel like over time, probably sooner than we think, there are going to be other ways of thinking about problems. Yeah, exactly. As you're saying, other ways of designing these systems such that that's going to be okay. And that's super fascinating that, okay, jets, yes, maybe there are millions of tiny errors, but if they're all immediately course corrected in some way constantly, then, well, what you get is something a million times more agile and more stable than an inherently stable craft. Okay, maybe it's not as stable, but it's basically it's not going to crash the same amount. Yeah. And it's going to be able to be so much more powerful in other ways. So I'd imagine something is going to happen in this space that's going to be very similar. And I can't imagine what it is now because it's the future and it's crazy and things are happening so quickly. But I think we should just continue to expect the unexpected and for our sort of API design paradigms to shift dramatically. And it's just fun to play around with this a little bit, this sort of way of working, because it does, yeah, it gives you an intuition a little bit for this new set of constraints. And if we could maybe enumerate them just a little bit, like a few obvious things are happening. If I go back to the actual prompt, let's have another poem about the weather with some math in it, maybe, or maybe not. We'll see if it decides to include the math. One thing to notice is just how damn slow this is, right? It's adding some numbers, getting user city. Okay, there we go. It's a long time, especially for, getting the user's weather right. We could do this pretty quickly with APIs. With addition, we could just use the built-in, oh my gosh, this one looks good. Oh, it's hilarious. Tokyo's covered in bees now. But anyway, it's slow between the messages because, well, the AI has to read this whole prompt and the whole history of messages to understand the context and to understand what it's even trying to do. And then it needs to, basically what takes the longest amount of time, and it really hung for this one, is to generate the next tokens, right? It's basically the way these things work is based on the past tokens in the conversation. It's slowly, token by token, generating the next token. What's the next word? It's basically extemporizing. And GPT-4 in particular is a bit slower because it hasn't been optimized yet and it's newer. I'm sure it's going to speed up dramatically. I mean, we haven't had it for only a week now. GPT-3 came out and then they made it like 10 times faster about 4 weeks later. I'm not sure what the actual timescales are going to be because so much of this was already being worked on behind closed doors and they kind of just opened it up to the public really quickly. So it's giving it this sense that it's moving at an insane clip, but I mean, they've been working on GPT-4 for at least a couple of years now. It is all an insane clip, but anyway, the point is, one thing for now at least is that it's slower in some cases. So that's something to note. It's not going to be applicable to every use case, but there are possibly other ways of also working around this. So one thing that I would like to do, basically the cost of each message is quite expensive. So if I'm going to push this to GitHub after this thing, Automaton, take a look if you'd like to. But one thing we can do certainly is instead of currently, I basically limit it to, hey, send me one RPC message at a time at most. I messed around earlier with having it send multiple. and it was fine. And what it actually tried to do at some point was send multiple, but kind of reference other ones in the JSON in a way that, like, I didn't write that syntax. It's not going to work. I'm not parsing that. But that would be great to basically build sort of a mini language and a mini RPC language where, okay, it knows that it's basically going to take the result of this you get user city and pass it in to get weather. That's part of its plan up front, right? It's going to get the user's city and then pass it into this. It doesn't need the city beyond that. It would be great for it to be able to sort of describe that composition in one effect. Similarly, to describe all of these things and get them in one thing. And really only break. We can sort of think about it similarly to like ZIO query of these can all be parallelized, and then but it needs the responses for the weather and the city for it to be able to write its beautiful poem. So to give it a language, a mini language to write its responses in, that we could parse and then actually execute in parallel, give the results back, letting it know which calculations corresponded with which results. And that all is cool. So that's one of the limitations. Anyway, I'm just kind of thinking out loud, like some things I want to do here. If I go to my service, chat service, I had some to-dos at the top. So yeah, allowing for multiple actions at once is definitely a big one, because speed is one of these concerns here in this new sort of API design realm. Another one would be another feature is to like allow for further user input or making selections based on past inputs. So if it needed to confirm something like, hey, here's the email I want to send to your mom, should I do this? Or to ask for feedback if something weird happened, it'll be allowed to basically trigger various interaction paradigms, maybe multiple choice, Q&A, whatever. But I mean, it's really weird, once again, having written so many APIs, to just be able to basically dump strings to this thing. Like for instance, when I give it my repos, what I'm doing, I'm just stringifying the repositories and sending those along. Like here you go, interpret this. Actually, I think I made a 2-string method. So it knows what the fields represent. So that the last number is stars and not some ID or something. But really, you just need to give it some string representation. And obviously thinking about a compact way of doing that is probably important as well. None of this is really optimized for that. But yeah, it's fun to play around with, and just to feel your brain kind of replasticizing itself around this new way of working, where none of your previous, or very few of your previous assumptions hold for what's possible. Yeah, or where you should even start exploring. It's just really exciting. Anyway, it's mostly talking because I don't know. It's so freaking insane. That's like a possible. How did it do that? That's wild. Anyway, do we have any questions on the Discord meanwhile? Or I'll get back to the implementation now. But I wanted to philosophize a little bit.
Yeah, philosophizing is good.
Great.
I think we are good here.
Okay.
Let's see. We have one thread. Okay, people are just mainly just saying hilarious, and yeah, they want to see implementation. So,
okay. All right. Let's do the implementation then. It's 80 lines of code.
It's a prompt. It's text.
Half of it's a prompt. Okay. And of course, a lot of it's Vigo's wrapper of the API. So how does it begin? Well, we have this prompt message that takes the user's command, the user's prompt. I log it, and then I have this messages ref, because we need to keep track of the previous messages, right? In between each of these sends. Basically, the way it works is, if you haven't used it, I mean, you probably if you watch the previous session with Adam and Vigo for just an overview of how their APIs work. But for the chat APIs, just as a recap, you need to basically send it the complete history, going back to the beginning, if you want further messages to, if you wanted to have memory of the past, essentially. And it always generates the next message. So you send it both, basically, the messages that you sent, as well as the past messages that it sent. So it can sort of add its next message to that conversation from its perspective, its role. So you have the role user, that's you as the user, and you have role assistant, which we add later on somewhere. New message. Where do I do that? Oh, yes, response role, but that's always going to be as an assistant. Anyway, so we start by appending or updating our messages ref, which starts, this message ref starts with just one message in there, which is sort of the system message explaining the procedure, explaining this. It's just prose, explaining the RPC and everything. We're gonna get into that in a minute. And it's a bit long, but that's okay. It kind of grew as I slowly shaped it based on it screwing up in various ways, and I just added clauses to it. It could probably be refined or made shorter. The shorter you could make it, the cheaper using this is going to be, the faster probably as well, fewer messages. But I wanted it to work anyway. Definitely something that could be played with. Anyway, so we start by adding to our running list of message history, essentially. This is our history. I guess I could call it history ref. And then we enter a loop. And I have a max depth here just so it doesn't go crazy for now. So it can only loop a certain amount of times before it explodes, because each one of these loops is basically going to trigger, ask it for another response. So we start with the user's prompt, and then what do we do? We get all the messages, and then we send it to ChatGPT, and we get a response. So then we get the first response off of there. We get a bunch of choices. We just get the head one, and it might not have a message, and then whatever. So boring. We just get the first message there.
Who would have thought that those little exercises of like implement like a console interaction with ZIO could be so useful?
Exactly. It's something. It's not too different from things that we've done before, and it can certainly be cleaned up. I'm sure it's kind of ugly, but it's all in just one thing. Okay, so we get the response. Then we have to wrap it up in this new message so we can add it to the history later, because it comes back as a different type. It comes back as a response message, but it has the same fields. So I just do this so we can append it to the history in just a moment. Okay. And then we get the action, or we try to get the action. So we get the response's content, and we try to decode an RPC call from it. So we have our RPC call decoder, which, as you see here, is an RPC string and then an array of any, which indeed our any decoder is just trying to decode strings, ints, longs, or booleans. So eventually, we probably don't want to use JSON. Maybe, I mean, it knows JSON well. It knows JSON well because the internet uses JSON a lot. But it would be interesting to see what sort of other protocols you could get it to reliably generate and adhere to. But for now, I didn't feel like messing around. I just wanted it to get me stuff, so I used JSON. Another to do, as I kind of mentioned, is allow for user data types. Basically anything you can have a ZIO schema for. But right now, the args in this array can really only be strings, ints, longs, booleans. We can have AI generate some more ones. Double, clearly. What else are you thinking of? Float. Okay, sure. Boring. Okay, so all that stuff. Yeah. Let's go back. So we try to decode a message. And otherwise, if it's not a message, we just decode the content as a string. That's something I want to work on. But basically, the RPC are currently only for the API you provide. And then once it gets a normal markdown formatted string, ideally, that's going to be sort of the end of the line. It's the final message. So right now it's, I basically tell it, as we'll see in a second, write a bunch of RPC calls to do the actions that the user requests, and then finally give a summary of what you've done in just a plain markdown message. I should probably also make that an RPC call and just sneak one in there. That's my plan, but didn't do that yet. So we get the action, which is either an RPC call or a string. So a left or else either is a nice combinator. So if this fails, this will be on the, if this succeeds, this will be on the left, a successive left. And if it fails, then we're going to succeed with a right of the content. And then I match on that. So on the left, we have an RPC call. So I log it. That's that yellow thing we saw before. That's the log. Then we actually call on that action handler, the RPC call. So we pass it along our service instance that we got from the environment, as well as that RPC call type that we parsed out. And then our macro generated this call method that basically that map of method name strings to function implementations, the calling methods on this service. So it'll just call the right method on that service with the arguments passed along. So that could fail as well, because we're just passing it along an untyped array that we're doing casts on. So if the AI didn't pass us the right arguments, well, then we're going to blow up, and I should probably handle that. But right now it's just going to die, I think, or I know, I think it'll just fail. In some way it'll fail. Cool. And then we get the response, which is any, because, we don't know which method they called, so that we're getting something back. Then we're logging the response after an arrow. So that's what this is. So we called the thing, we got the response back. Okay. Then we update our ref. Now we can update our ref with two new things. The new message, that's what the response was. I guess probably rename all this stuff. Response message. And then we have a system message with the response. So this is sort of, there's three characters in this play that the AI is generating. There's the user, that's us asking questions. There's the assistant, that's the AI's character, and then there's the system, which kind of can interweave in there as a third personality. And I'm using the system role to both sort of inform the assistant of the rules of the game, and also to provide sort of feedback from its RPC calls. Great. And so yeah, so so the next time it loops, which we're doing right away, it's going to see its response, basically its RPC call, and then it's going to see the response to its RPC call. So it'll have that now in its history, and it can make further requests based on that, which it will. It'll prompt it to get another request, which will either be another RPC call, or eventually it'll be the final response, which is exactly what's happening. So we're getting RPC call, and so each time, basically, this is each one of these is another loop. So it's going to see this history, and it's going to see this, and it's going to see this, and so on and so forth. Yeah, and it's going to see one special message at the very top, which is basically the instructions of what it should do, how it should send its requests, etc. And it sees something a little different than this, because it's going to see its actual JSON, not our parsed version. But other than that, that's basically what it's seeing, until it finally ends with its string response, which we log again. Just different colored responses is all this is. Very tacky. Different console colors. And then, so half of this is the prompt. So we could just read the prompt. And I just basically, why it's so long is I kept adding addendums, like a long contract. Like I felt like a really,
you're a lawyer here.
I felt like a really bad lawyer. This is I mean, yeah, it's not fine print, but yeah, I kept adding fine print essentially until it stopped exploding in various weird ways. And you can kind of tell based on what I'm writing. I'm not sure if using all caps helps. I'm not sure if being mean is better. It on their docs, it's like usually that starts with a gentle guidance, like you are something, you are an RPC calling bot. Maybe I should do something like that.
I know there was the one of like, you are hustle GPT, your job is to like make money with $100 and just setting up like affiliate marketing.
Oh my God, that's amazing. Yeah, this could really make that more optimal.
There was also I don't know if you saw, there was the person who said they had neuroinversitis.
Oh yes, where they got it to, oh my God.
Just be very mean to them.
Yes, they said they had a disease where they interpreted the opposite intention from all sort of spoken words, the opposite emotion. What's the disease called?
I think it was like neuroinversitis. It's not a real disease as far as I know.
No. Oh, that's amazing. So yes, you can screw with it in various ways, and that's the art of prompt engineering, as the internet calls it. But there are lots of sort of weird spammy type accounts that want you to sign up for email lists. But there's definitely something to it. But I'd recommend, there's probably enough free information out there. But if anyone wants to play around with this and just try to make this prompt better, that would be great. But let's read it together as sort of our ending exercise. So you can only answer in RPC calls. Yes, one at a time. Your final message must be only marked down. I was getting a lot of situations where it would, in its final message, would be sort of the summary, and then one last, like, I'm about to send your email. here you go. It's like, well, that's not parsable for me, please. So please just one at a time. But ideally, I could just make the RPC format more general and then not have this weird distinction between different message types. But anyway, this is hacked together in a few hours. So you have access to the following RPC calls. And then we print that description, which is basically, if you remember those lists of def, this, like it looks like that. So it's just a bunch of methods. To send an RPC call, reply with the following JSON: RPC string args any. Cool. So it learned that pretty well. You'll receive a response for each RPC call after you send it. You can only send one RPC call per message. I maybe don't need that, but it was trying to do weird things sometimes. Only use actions relevant to the request. You don't have to use any actions if they're not helpful. That's because I tried to ask it questions. It basically tried to use everything in every request, even if I was just like, tell me a joke. And it didn't need the weather. It still like looked up the weather to involve that in the joke somehow. And it's like, okay, that's clever, but the user didn't in any way really want you to look up the weather. So that seemed to prevent that from happening. Once you are done sending RPC calls, finish with a final markdown message to the user. Your final message should be markdown formatted. This will end the conversation. To summarize, send one RPC call per message, gathering information to fulfill the request, then send the final markdown message to the user. Do not send anything else. Only use markdown for your final message. I was getting frustrated. It kept doing that. Eventually, I got it to not do that. Your final message cannot contain any RPC calls. So if you want to send an RPC call, send it before your final message. Do you get it? Do you get it, AI? I could probably delete some of these. Example. These are just examples. The actual RPC calls you have access to are listed above. That's because guess what? It tried to use these sometimes, even if they weren't in the actual API. And then I show some examples of an RPC call, receive response. An RPC call, receive response. Your final message in markdown format. Yeah, that's basically the prompt that gets it to work, which is, it can probably be winnowed down, but you know, it hasn't failed me since in this format. So that's pretty great. Yeah, it's kind of insane how much attention it pays to detail. And okay, maybe I need to say some things multiple times sometimes, but I could probably also just try rewording it or just make it clear. Like this, I wouldn't say this is the best written prose ever. I was kind of being lazy about it at the beginning. So maybe if you're just really precise and good at explaining things, good at writing, that could be a good skill. I think we've often say that like a lot of programming day to day is really more linguistics or just writing and organizing than, you know, certainly than math most of the time. It's about communication skills, and really it might shift more and more towards just being really clear, being a very clear communicator, and you know, identifying ambiguity and resolving it. I think that's the one skill that developers build more than any, is just to be able to identify ambiguities and just keep breaking them apart until there is nothing, until they're dust, until there's just dead, dry earth, unambiguous earth. Cool. And that could probably help you when trying to control a giant evil genius thing, to send your emails to your mom to schedule lunch. All right, well, that's basically, that's it. I mean, there's some macro stuff in here that does the thing to get those, to generate that, that map of methods. I had another version in here as well that I commented out, where you give it a, I'll go to the other example I have somewhere. Did I just delete it? No, here it is. I made another version of this API that instead accepts an enum, but then I was like, you know what, I want to make a macro because I don't want to have to, you know, build an enum and then build a interpreter for the enum. Let's just have just write the trait. That seems more fun. But maybe that'll be useful as well. So I don't know, I just leave it commented out. Yeah, but that's it. Any final questions? This is just a dumb console loop.
All this stuff is super cool. I mean, it's just such a technology. There's just a lot of things for us to explore with it.
Yeah, it's gonna just keep thinking about it. How could you integrate this to make your life easier, to do fun things? There's tons of crazy stuff out there. Seen some people use it to make some weird like interactive games where you're doing various things. there's a really weird one that I saw where there's like a little emoji of a Rastafarian wearing a hat, and your goal is to convince him to give you your hat, which may be a little problematic, but as a weird thing, it seems very creative, at least. Yes, the guy made a series of games where you just try to convince people to give you their stuff. And you have to sort of argue with somebody who's playing a role and speaking in some sort of dialect generally, which is maybe a weird thing. But anyway, it was one of the more creative uses I've seen so far. But I'm sure this is going to be in, RPGs. It's going to be in everything. I mean, they just like drop this weird atomic bomb into the public. And hopefully it does cool things before it dissolves all of us into protein goo.
Yeah.
Let's go. Anyway, that was really fun. So I'll push this code up and share it in the Discord, and yeah, automaton, it'll be on my GitHub somewhere. So muck around. Let's end with one last haiku about the weather. And until next time, thanks, y'all. All right, start with a nice number there. Get the city, Tokyo again. I'm probably going to be covered in bees again. Yep. All right. My randomness isn't very random today. And ooh, okay. A Day of Weather by E.E. Cummings. In Tokyo so grand, covered in bees land. Covered in bees lands. The sun does hide as we gently glide into a realm of fantasy. Oh, and 2156 plus 2366 is 4522, dear.
Dear, very intimate.
Very good.
What have you been getting up to with ChatGPT here?
Oh, thank you, dear. I'm not sure if that's an E.E. Cummings flourish, but yeah, it is very good at adapting the style of various poets, or just, yeah, it knows a lot. Give it niche things and it's gonna freak you out with its knowledge of like yeah, random books that basically you don't think many people have read. It knows them cover to cover pretty much, obviously, because it's been trained on it. Anyway, with that, we bid you adieu. Thank you, Adam. That was a pleasure.
This was lovely. All right, bye.
Till next week. Bye-bye.